Newton's first law of motion. We have some pretty cool demos for Newton's first law. If you select Teacher Resources after clicking the link below, you'll see them. And then the video below provides instructions on how to facilitate the demonstration, so please click there for that video. Sir Isaac Newton was a brilliant mathematician and physicist among many other professions, and that would be good to Google that and see what else Sir Isaac Newton did in his life. Perhaps he is most famous for his 3 laws describing motion and his law of gravitation. Newton's first law of motion. An object at rest remains at rest, and an object in motion remains in motion unless acted on by a net external force. In other words, an object maintains its velocity, which is both speed and direction, unless acted upon by non-zero net force. Having zero velocity, which is another way of saying being at rest, is not special. It is just one possible velocity, a velocity which is no more special than any others. The first law is also known as the law of inertia. The word inertia comes from the Latin word iners, which means idle or lazy. Another definition here, inertia is the tendency of an object to resist any change in motion. So if the object's at rest, inertia will help keep it at rest. If it's in motion, inertia will keep that motion going. And here is an interesting demo that you can click to illustrate the principle of inertia. Newton's laws are only valid in inertial reference frames. And we've only shown one law, and we haven't even talked about reference frames yet. But an inertial reference frame is one which is not accelerating or rotating. And all a reference frame is here you're walking. Let's say you're walking down the street. We can say the reference frame is the ground. And relative to the ground, your position can be discussed. And also your motion, your velocity and your acceleration can be discussed. So that's a reference frame. It's just something you measure your position, velocity, and acceleration from. An inertial reference frame is a special one. It is not speeding up or rotating. Every body in an inertial reference frame remains in a state of rest or a constant velocity unless acted on by an external unbalanced force. So we're taking Newton's first law and we're limiting it to inertial reference frames. So what is not an inertial reference frame? Let's wait for the next slide. If you're in a car and it's accelerating, which means it's speeding up or slowing down, we do not have an inertial reference frame. So what does this mean? Let's say I have a cup of coffee here on the console and it's not supported by anything. Not a great move. If you're moving at a constant speed, it'll just sit there. But what happens if you speed up? You are no longer in an inertial reference frame, so Newton's first law won't describe the motion. So what's going on? The cup flies backwards, seemingly, and actually there is no external net force on it. It just moves. Now, the only way it can move is to have an external net force if you are in an inertial reference frame. So what happened here? Well, what happened is the car started accelerating. The drink tried to stay at rest, and it couldn't because the car just accelerated out from under it. So from the point of view of somebody in the car, that cup moved backwards. But in reality, it was staying in the same place and the car accelerated forwards. Bottom line, it fell backwards inside the car without any net external force, so Newton's first law is not valid in a non-inertial reference frame. And that's a lot of words, but here, click here. This will help show you and explain this a little more.